Hi everybody. Today we're going to work on lesson 3 in our probability book. So yours is probably yellow. It's not nice and colorful. Did you read this, by the way? You're kidding. I was struck by lightning. Struck twice by lightning too. What are the odds of that? Regardless, we're going to go right over to lesson 3, experimental versus theoretical probability. Most of the time you can find the probability of events using math. But sometimes you can only find the probability by conducting an experiment. So an experimental probability is what's going to happen in real life. Okay, so in theory, it's what should happen. An experiment is what does happen. So let's look at an example. If a coin is tossed 10 times, the theoretical probability of it landing heads is 5 out of 10. However, if I actually tossed a coin 10 times and it lands up heads 7 times, then my experimental probability is 7 out of 10. So what should have happened, in theory, was 5 out of 10. But what did happen in my experiment is 7 out of 10. And this is what that might look like. We're going to put some stuff into charts when you do some experiments. So, in theory, the probability of rolling heads is 5 out of 10. And again, if you can't reduce the fraction, don't sweat it, okay? But my experiment got me 7 out of 10. So my theoretical probability, 5 out of 10, is 50%. If you can't remember how to do that, what we did was 5 divided by 10 equals 0.5. Turn it into a percent by timesing 100, and I get 50. My experimental probability, I rolled heads 7 out of 10 times, and I got, 7 out of 10 times. 7 divided by 10 is 0.70. Move the decimal twice, or times 100, and I get 70%. So the difference, now this is where some kids go wrong. The difference is always the experiment minus theory. So 70 minus 50. That gave me a positive 20. Now for rolling tails, obviously, if 5 out of 10 should have been tails, only 3 out of 10 were tails, right? Because 7 were heads and 3 were tails. So 3 out of 10 is 30%. So my difference is 30 minus 50. So 30 minus 50 is negative 20. The whole point here is that the two numbers I'm adding up should add up to 0. That's how I know I did it right, okay? So maybe always make a note that the difference between the theoretical and experimental probability will always average out to 0. So even though your results might vary over time, in the long run, your experiment should eventually match the theory. Okay, let's look at another example. This is a hard page to read, but it's really not. In a jar of jelly beans, there's 4 left. We've got red, blue, yellow, and purple. So the theoretical probability of selecting a purple is 1 out of 4, which is 25%. So, but if I actually reached into the jar and marked down which color I took out, and then of course I put the colors back so that I've always got 20, this is what might have happened in my experiment. I pulled out 4 reds, 7 blues, 6 yellows, and 3 purples. But in theory, after 20 selections, I should have pulled out 5 of each color, right? I should have pulled out of the 20, 5 red, 5 blue, 5 yellow, and 5 purple. So in theory, my percentages are all 25%. They have a 25% chance of being selected. But here's what actually happened. My 4 red, my 7 blue, my 6 yellow, and my 3 purple. These are the percentages I got. So the difference when I go experiment minus theory, 20 subtract 25 is negative 5. 35 subtract 25 is positive 10. 30 subtract 25 is positive 5. And 15 subtract 25 is negative 10. When I add them all up, I get an average of 0. So I know I did it right. But now let's look at this. What if I pulled those jelly beans 100 times? Well, I would still, my theory doesn't change. Because now, out of 100 reaches into that bag, I should have pulled out 25 red, 25 blue, 25 yellow, and 25 purple. So in theory, it doesn't change. But my experiment might have. This time, maybe I pulled out 28 reds, 22 blues, 23 yellows, and 27 purples. And so here are those percentages, right? So when I do my difference, which again is experiment minus theory, 28 subtract 25 is positive 3. 22 subtract 25 is negative 3. 23 subtract 25 is negative 2. And 27 minus 25 is positive 2. Notice that they will still all add up to 0. But what if I go for 1,000 tries? What if I pull those damn jelly beans out 1,000 times? Again, 250 of them should be red, blue, yellow, purple. So my theory doesn't change. No matter how many pulls, in theory, in a perfect world, I should pull each color 25% of the time. But my experiment, this is what actually did happen. These are the numbers I got. Now, again, when I find the difference, experiment minus theory, 24.7 minus 25 is negative 0.3. 25.3 minus 25 is positive 0.7. 24.5 minus 25 is negative 0.5. 25.5 minus 25 is positive 5. But they still add up to 0. But I want you to notice, these numbers are quite far. These are quite large differences. Smaller differences, negligible differences. These are like nothing. So this is what's important here, this note. This is kind of a test question. The more times you conduct an experiment, the closer the experiment results will be to the theory. And the differences between the two will approach 0. Okay, that's important. So the more times you do it, the more times you're likely to reach what should happen. Now, you're going to do 2 experiments, and I'll walk you through the first one. So you get a dice. If you don't have a dice, you can use the dice app on your phone. So there's no excuses for this. So suppose I roll my dice. I got a 5. I just keep rolling it. I get a 6. I get a 3. I get a 6, and so on. Then I'll add up what I got out of my 60 rolls. But in theory, out of 60 rolls, I should have rolled a 1 10 times. I should have rolled a 2 10 times. Now, how did I know that, by the way? 60 rolls divided by 1, 2, 3, 4, 5, 6 outcomes means each outcome should happen 10 times. So my theoretical probability, 10 divided by 60, is 0.11166. Let's make things even numbers. I should have got I should have rolled a 1 17 in theory, sorry. I should have rolled a 1 17% of the time. And I should have rolled a 2 17% of the time, and so on. But now in here, you're going to put down whatever percents you got. You're just going to transfer them over here. So if I got 20%, I'll write it here. And then I'll do my experiment minus my theory. So suppose I got 20. I'll go 20 minus 17 is a positive 3. Okay? But I'm going to erase that because your results will be different. Everybody's results will be different. So I want you to do this experiment. So in theory, what should happen? And in my experiment, what did happen? Now, your second experiment is kind of fun. Suppose you closed your eyes. Oops, here we go. Suppose you close your eyes and try to draw freehand a 20 centimeter long straight line. Now, what does that look like? 20 centimeters. I don't have a ruler handy. Mine all have inches, and I'm tired. So let's see. I found my tape measure. So 20 centimeters should look like that. So on a piece of paper, a 20 centimeter line should be about that big. Okay? So I'm going to close my eyes and draw 12 freehand lines. I'll just turn this sideways for a second. And so on. I'm pretty good at this because I've been doing this a long time. Okay? And then I'm going to measure how many of my 12 lines were exactly 20 centimeters, how many were bigger than 20 centimeters, greater than, and how many were less than 20 centimeters. So my first line, let's take a look. Oh, it's around 19. Don't worry about the curves. Let's just go dot to dot. So I got one that was less than. I bet you hardly have any that are exact. It's actually hard. This, oh, I got one. Here's one. Mine, I got one. That's 20. But I got to do this 12 times. So ooh, that's a little, I'm going to call that close enough. This one's a little less than. So you're going to do that 12 times. And then again, you're going to put in what should happen in theory. Okay? You're looking for 20. You're going to roll the dice 12 times. Divided by 1, 2, 3 possible outcomes. Each outcome should occur 4 times. Okay? So I want you to finish that up. And your difference should be 0. And then you're going to answer the rest of the questions. And that's it. That is lesson 3. Stay tuned for lesson 4.